Hello everyone. Today we are going to discuss a superbug called Pseudomonas aeruginosa. Is it an infection that can't be treated? Pseudomonas aeruginosa is defined as a superbug. What is a superbug, you ask? Well, they are specific strains of bacteria that are resistant to several types of antibiotics. Antibiotic resistance occurs when these strains of bacteria change so that the antibiotic medicine can no longer kill them or stop their growth. These superbugs are a growing threat to society, and according to the CDC, they infect more than 2 million people nationwide and kill around 23,000. However, scientists estimate that by year 2050, superbugs could kill 10 million people a year. That is around the same amount of people that cancer claims. There are multiple strains classified as superbugs, like methicillin-resistant Staphylococcus aureus, otherwise known as MRSA. But today we are going to focus on one specifically, and that is the multi-drug resistant Pseudomonas aeruginosa. So why is Pseudomonas aeruginosa a superbug? Simply put, it's difficult to treat because most antibiotics aren't strong enough to kill it. This bacterium has multiple mechanisms of antibiotic resistance, such as antibiotic inactivating enzymes or efflux systems, which allow it to eject harmful compounds away from its cell membrane. It also causes a wide variety of infections like pneumonia and ear infections to endocarditis and meningitis. Pseudomonas infections quickly evolve resistance due to a gene that mutates at a rate 1,000 times higher than the normal rate of mutation. This is all very daunting, right? So you may be asking, is there hope? There have been recent developments in what are called multi-epitope vaccines. Multi-epitope vaccines are a new type of molecular vaccine that encode multiple target and supporting antigens. There were two designs shown to have promising results against Pseudomonas aeruginosa. One was a bacteriophage designed vaccine which had a strong ability to simulate an immune response in our body, while the other was a cell wall associated transporter designed vaccine which had a strong influence on toll-like receptor pathways, which are pathways in the immune system responsible for recognizing bacteria or pathogens and inducing the innate immune response in our body. In fact, there was a recent news story of a lady who was battling with lupus her whole life and had developed a cancerous tumor in her ear. She was treated with multiple antibiotics, however, the bacteria in her ear had become resistant to antibiotics. Doctors offered to treat her ear infection with a bacteriophage, which are designed to attack and consume bacteria. The bacteria cultured from her ear turned out to be a rare strain of drug-resistant Pseudomonas aeruginosa that had actually infected many other people who had used a recalled brand of eye drops. Using the bacteria cultured from the lady's ear and other samples from people with the eye infections, scientists were able to identify a dozen bacteriophages that were able to be used successfully to treat and kill the deadly Pseudomonas pathogen. So what's next? Antibiotic resistance and the development of superbugs are a serious threat. When getting treated, ask if antibiotics are the only course of treatment, or if there is anything else you could do. You may not need them, but if you do, take responsibly. Lastly, there may be alternative therapies on the horizon. Will bacteriophage treatment be a new solution for this superbug crisis? Could this little virus defeat bacteria when all drugs and medicine could not?